You're listening to Gradient Dissent, a show about making machine learning work in the real world, and I'm your host, Lucas Bewald.
Well, so I've been asserting that the cost of AI is going to be dominated by production efforts.
Rodrigo Liang is CEO and co-founder of SambaNova Systems. What's really impressive about SambaNova is that they provide a complete solution to their customers, all the way from custom hardware that they've built to enterprise solutions that are completely use case specific. I think what I really took from this interview is what it's like to talk to executives at large enterprises and how to convince them of the power of machine learning and how to integrate machine learning applications into their company. I hope you enjoy this interview. The place I wanted to start is, I'd love to hear about your company in your own words. I mean, both what it does and the story of how you started it.
Yeah, we started this company back in 2017. This was pre-COVID days, and people were getting excited about AI and looking for different ways to compute it. And so my two co-founders are Stanford professors, Chris Ray and Kunle Olukotin, and they were doing some work at Stanford around how to find other ways that we could actually provide better computing for different types of AI workloads. And so I was at Oracle at the time and building microprocessors for the Sun line of products, and we had one of the largest chip teams in the Valley. And we came together. We decided that, look, it's time. The AI is too big of a transition for the world not to have some choices on how to actually compute it differently. And the Stanford research had gotten to a point where it looked pretty promising as far as what it could do. And so we came together, brought a bunch of amazing people together, brought a bunch of really great investors together, and we kicked it off. And really, ultimately, we've now created a platform that's focused on enterprise. They're really building a full stack technology. And everyone's saying full stack, but when we talk about full stack, it's chip to model, right? And so being able to give you a trillion parameter class model, fully integrated, fully optimized on hardware, so you can roll it wherever you want, even on-prem, and be able to train on your private data without disclosing it. So that's really what we focus on, and that's kind of where we've been for the last six plus years.
It does seem like an interesting point of view to build software and hardware at the same time, especially it seems like you build software that goes kind of all the way to the end use case. I guess, what are the pros and cons of doing that?
It's interesting because you hear Sam Altman talk about wanting full stack, would build his own chips, and you find others that have built these large models trying to figure out how to actually get into the chip game, because it is expensive. It's extremely expensive to be training and inferencing these models on somebody else's infrastructure, and especially if you're doing it on generic infrastructure that doesn't understand enough about the models. And so one of the things that we've been able to take advantage of since we build our own chips, we manufactured those through TSMC, and we build it for our products. We're able to take open standard, open PyTorch-based models, the best of the open source. We can integrate it into the platform and provide you the highest performance without you having to do all that tuning work yourself, right? That we can see what are the models that people want. We can curate the enterprise class type of tasks that people want, and we can actually select, and then we pre-tune and pre-optimize. Companies like Google and Meta and OpenAI are able to attract all of that talent, but most enterprises have a hard time finding machine learning people. And so by being able to actually provide these fully integrated systems where the models, these complex models, are already pre-tuned, pre-optimized, it's running at full performance at the lowest power, and you can deploy those already pre-configured for the enterprise use case, becomes an accelerator, right? We can roll these racks in. You got 1 trillion parameters already pre-optimized in there, and you can chat to it the way you would chat on GPT-4.
I know these models, these chips are typically delivered into a data center. Like, how would it work if I'm using a cloud provider already, would that even make sense for me to work with you?
Yeah, so we deploy anywhere, and so you get, if your data or applications come in through GCP or AWS or Azure, you can come through a secure pipe into these racks, and many of our customers do that. In fact, they come in and they're able to then begin some of the workloads where the data sits either on the cloud or their data is public, and so they can start doing some of that work. But where we're highest value is where the customer wants to actually bring that same platform, the same model, the same infrastructure, the same tasks, and bring it into fine-tune on their private data, right? In those cases, then we can actually take the work that was done on the cloud, mirror it on a set of racks that we can deploy on a private cloud, right? On-prem, in air-gapped environments even, so very popular in the public sector, U.S. government, and other governments, very popular in the financial sector, healthcare, energy, right? Anywhere where you have a lot of data that has to remain local and remain in a certain premise, we're able to take whatever work you did on the cloud, replicate it on racks that we can deploy on-prem, and then you can fine-tune every expert that is in that model with your private data without ever having to disclose it into the public domain.
And your background is in hardware, isn't it? Is that right?
Yeah, I mean, for the most part, we tried not to admit it too much. It's, I did my graduate work at Stanford and EE and started working on chips back at Hewlett Packard when we were building these high-end servers for computing back in the mid '90s, and then of course spent the last prior to starting this company, spent the prior 15 years building high-end computing solutions for Oracle Sun, which included the chips and the systems, and then of course some software that went along with that. And so much of my career has been spent doing full stack solutions, building chips. The thing I tell people, I've built chips. I've designed and taped out dozens of chips. We've shipped hundreds of thousands of chips into the market, and we've never actually sold an individual chip, right? Because we only sell it in the construct of a solution or system or platform that allows you to actually take advantage of it. That's the way that we feel like it enables the end market to be able to take advantage of this technology. Otherwise, it's just too hard. It's too hard because you got to teach people a new language, a new programming paradigm. You got to go on, teach people how to compile it and have to optimize for performance. I mean, it's just too hard, right? And so much easier for me to say, hey, if you like GPT-4 and the APIs that you get on GPT-4, you get the same through SambaNova. It's much easier to say that and to do that. But for that to happen, you have to do a bunch of software and modeling work in order to take it all the way to that level of abstraction so that people can interface to it in a way that they're accustomed to.
I mean, I guess there would be another way to make a company like that, though, which is to take, kind of commodity hardware and, kind of build that same layer of abstraction on top of, somebody else's hardware, right? So do you think that there's some special advantage you get in the way that you've designed these chips? I mean, my background, to be clear, is completely software. So I know very little about hardware. So you may need to, dumb it down for me and the audience, but I'm really curious about how you think about that.
Well, so what we wanted to do was make sure that we could drop an enterprise grade model wherever the data was, right? So if your data is fully in the cloud, then ultimately it's just about cost and power, right? Mm-hmm. But if your data is on-prem or in different private clouds and in different pieces, and you want a trillion parameter model in the size of GPT-4, it's impractical for me to roll in 10 racks of hardware, right? Which is more or less what it would take for you to run a trillion parameter model these days, right? And so, but by having our own model all the way down, optimized all the way down to the hardware, we can do it with as little as a single rack, right? And so there's a 10x compression and footprint because we can take these large models that people want for the enterprise. They want to fine tune it on their private data. They want to actually do single endpoint inferencing in production across a trillion parameters, but you want to do it in a small footprint, right? And so being able to have your own hardware allows you to collapse it in such a footprint that Now you can ship it wherever you want. It's not just about cost, it's about power, it's about cooling, it's about manageability, less infrastructure to manage. It's just less, right? When you can take a trillion parameter model and then run it in a very, very small footprint of hardware, which is ultimately what we were able to achieve when we do it ourselves.
I see. So your thought is you can run kind of bigger models on a smaller amount of hardware. That's sort of the benefit that you get, and then you translate that into like a essentially like applications for your customers.
Right. Well, we can innovate at every layer, right? So now we can build these large models. So we're going to some of the Fortune 500 and governments and some of the really complex environments where they say, well, I already have hundreds of models that people are doing and doing individual things, but really I don't have a way to manage it, right? I don't have a way to be able to have multiple models kind of work with each other in a seamless way. And maybe I want to try a bunch of different things, and it's not very easy for me to aggregate 6 or 7 models, try all the different combinations with them. And maybe what I want to do is have 200 models all live and be able to interrogate them concurrently, right? I want to be able to do a bunch of different things. So those are the types of things that we want to enable companies to be able to do, to be able to have a broad range of models where the cost of actually hosting those models and having them live collapses, right? That we can now take a single system and actually have hundreds of models all live for you. You can actually pick and select how you actually want to arrange them. You can use them concurrently. You can reuse them sequentially, like lang chaining them together. You can actually do experimentation across various different optimizations that you might want to do, but all within a single framework, right? And so it's not just about taking the largest model and hosting them bigger in a smaller footprint. It's a construct of it. Now, instead of a big monolithic model, like a 1.5 trillion parameter all monolithic, I can give you, say, 500 models, all based on open source mix. It's a combination of, say 50 Llama models and 50 Mistral models with 50 whatever, clip models. And you can mix and match all of those and then do line item veto. Like, I don't like this one. I'm going to swap this one expert and then put in a different one. And you can dynamically modify until you get to the combination of models that you want, where every single one of those experts is the best at that one task that you're asking it to do, right? So you don't have to kind of think, can I train one big giant monolithic and spend tens of millions of dollars training this to get good at all these 50 or 100 tasks? Well, I can go to the open source community, which is just amazing now. I mean, you look at how many people are inventing some great, models out there that do singular things really, really well. We can integrate them into the structure and give you access to all of them concurrently off of a single endpoint.
So when a new model like Mistral, comes out that people are really excited about, how long does it take you to get that model running for your customers? I would imagine you have kind of your own stack, so you really have to do it on behalf of customers. Like, are you able to kind of get them to customers' hands right away, or is it a lot of effort?
Yeah, usually, like, for example, depends on the model, I suppose. Like Mistral, I think it took us a week, right? It took us a week to put it up there. But because we do it in the construct of a trillion parameters, right? So it's not just, here's Mistral you can run on SambaNova hardware. Here's 50 copies of Mistral sitting next to 50 copies of Llama 70, or 50 copies of Llama 7 or 70 all intermixed. And you can pick and choose how you want to fine-tune every single one of those in your private data. Right, so that the work that we do is in trying to make sure that those public open source models, when they're available in the construct of SambaNova's composition of experts, right? So that you can actually access them through a single endpoint. You can actually have them interact with each other. You can actually fine tune every single one of those. So you can actually have them fine tune on data and plug it back in. And so those are all the things that we try to make sure it does. And so I think Mistral took a week. Some of them take a little longer. Just depends on kind of the construct of the model. And some of them we don't offer just because they don't add necessarily much value over what we have. And so we curate it for our customer, right? We usually will select the ones that we think for the type of customer we have, which is mostly enterprise customers doing these types of things. These are the ones that add value. Otherwise, we end up having so many that can actually train support, and then they have a hard time actually figuring out which one's which.
That makes sense. I guess we're in a much different world than at least, I expected when I was sitting there in 2017 and sort of looking at the machine learning landscape. I'm kind of curious, were there what were the biggest surprises along the way in building this company?
You've gone through a similar journey yourself. It's like the pace of change, right? The pace of change is just so fast. People start talking about one model, and you go home, come back to 2 new models that people are talking about, right? And just the ability to kind of stay with it and keep up with all the changes and be able to support them, I think requires to have a very robust infrastructure, right? That you have to be able to handle the broad range of models. For us, since we want to give our customers a fully optimized experience, right? There's no kind of go and fire up CUDA to optimize this on the hardware. We don't want our customers to have to do any of that, right? You take the model. If we say the model's there is performance optimized, accuracy optimized, it just works, then we have to actually have a platform that can very quickly do all of those things on our customers' behalf, so that they don't have to hire all those people that you and I know are really, really hard to hire and find, right? And so I think that's the pace. I think it's really it was a surprise that it lasted this long. Usually you see kind of the technology volatility kind of happen the first few years, but it continues, right? The velocity continues, and people are able to innovate and create faster and faster, it seems like. I think the other part of it that's kind of been really interesting is just, certainly you look at NVIDIA and what it's done. What a tremendous run, right? You look at kind of that infrastructure, and as much as they've grown and as much as they've kind of been able to capture a dominant position, you look at most enterprises, they're just getting started. Right? They're barely getting started. And so you think about, where's this AI market going to end up, right? You look at all these companies becoming billion-dollar companies just off of the excitement around AI, and yet my estimation is most of the world is just now getting going with putting things into production, and it really won't hit full stride for a few more years, right? And so I think that's the exciting part, and kind of really daunting part, that there's a lot more demand coming, a lot more interesting things that people are doing as people really figure out kind of what can really be done with AI.
Mm-hmm. Have the use cases surprised you? We see a quite different set of use cases at Weights and Biases than we saw even 2 years ago, let alone back in 2018 when we started. Could you describe the kind of arc of use cases that your company supports?
We're very focused on specific things that people were trying to do. When we started the company, there's certainly a lot of language models that people wanted to do, but we were also doing a lot of image models, right? We're doing some healthcare things. We were detecting kidney cancer with a partner, and then we're doing a lot of seismic analysis work for energy companies and looking at subterranean mapping. And so all sorts of different things. And the bigger the model, the better, right? The bigger the model, the better was our model. The harder, the more complex the model, the better we performed. And then OpenAI showed up with ChatGPT, and the whole world just snapped over to LLMs, right? That everybody, all they wanted was, can you generate language-based models for us, and generate it in the private, right? And so we took a very quick, what I'll call a detour, just to focus on LLMs, just to make sure that we could give people what they wanted when as far as training these very large models, trillion-sized models, for very various domains, right? Whether that's for confidential information, or for intelligence, or for pharmaceutical, where medical patient data was involved, or anything that couldn't be disclosed. That we did a lot of work focusing on that, so that people could take advantage of these Gen AI models in that context, in the private, and being able to actually deploy, truly fine tune them using that private data. And then as we went along, then we started getting into multimodal because people wanted to get back into the vision and doing vision along with text and being able to read charts and graphs and images. And so we have those now. And then now we it's all coming back together where these more complex use cases are now being done in a multimodal way with these language models. And so we're able to deploy them together. But our view of it is, look, whatever model you need to run your enterprise, whatever it is that you want, you probably always have some amount of language that's always going to be part of your model, right? Just because you need to talk to, you need to generate documents, you need to summarize documents, you need to, whatever it is that you need to do, language and graphs and charts are going to always be part of your base. And then depending on whatever else you're doing, whether that's drug discovery or seismic analysis or satellite image satellite image interpretation, any of those things, those become your specialized models that we can support. But we always see kind of the same set of base models that everybody wants around language and vision that becomes common across the base platform for these large models.
And do you, I know a lot of hardware companies seem to focus on inference or focus on training. It seems like you guys do both. Is there any trade-offs there, or do your customers tend to care about performance, more about performance on the inference side or more about performance on the training side?
Well, so I've been asserting that the cost of AI is going to be dominated by production inference, right? That's kind of what we're seeing out there as people go out there, that as much as a developer, we really focused on training performance. We really, with our latest set of products, we released our latest product in chip in the fall of last year. We did a big push forward on production inference because the more we saw our clients start getting into production, that became the overwhelming cost, right? That they just couldn't actually get the cost down. And so what we can now do is actually do a big reduction in production cost while using the same systems for you to do continuous inferencing, continuous fine-tuning, right? And so you can pre-train the models, which some number of people do, but once you're in production, they're mostly just doing ongoing fine-tuning and then inferencing, right? And so so what we want to be able to do is be most efficient when you're deploying these by the hundreds, when you're kind of doing at scale inferencing. We want to be very, very efficient when you're doing fine tuning while you're in production. And then also, when those machines are being used, you should also be able to actually have pre-training capabilities on the same machines at a very high efficiency, right? And so, we're proud of being able to train the largest models, and we're very focused on the largest models and being able to train as fast, if not faster in some cases, than the H100 GPUs from NVIDIA.
Do your customers typically have an ML team on their side that's working with you to get these things stood up and deployed? Or can they do it with just kind of like a software engineering team, or do they even need a software engineering team to kind of connect this to their business application?
We have a range of clients. So some of our clients, they just have some amazing ML teams. And so they're doing all sorts of model exploration, and they've created their set of models, and their use cases are very unique, and they see those models as their differentiation. And so they're quite capable of taking those, even if they kind of started them on NVIDIA GPUs, they can just run them on SambaNova, or they continue training or continue fine-tuning on SambaNova, or even in the ones that they actually have already pre-trained and they're using in production, they can just inference on SambaNova just because you get this 10x improvement in production inferencing footprint. And so there's a lot of mixing and matching that they do, but for those clients, they already have that expertise. They know what they want to run where, right? They know what they want where. They know what they're trying to do with it. And so for most of those cases, we just provide them a platform, an easy way to take any PyTorch model that they run and just kind of mix and match, and you can train and then refer somewhere else, or train somewhere else and refer here. You can do a blend. It just makes it easy, and they figure out what's the most effective for them. I'll say that's the minority of our clients that have that level of expertise, or they're able to train these complex models, get the weights right, get the accuracy right, make sure that they can continue to fine tune that. The large majority of our customers now, thank you to OpenAI, really helping educate kind of everybody on what Gen AI could do. The large majority now is really using as an API, right? They have some application of software engineers that kind of have learned how to do, some level of prompting, some level of interfacing into these large models, and then and they're comfortable there, and then maybe a little bit of kind of some data prep, but they're not training their own models. And so for those, we come in with the SambaNova composition of experts already pre-trained, pre-optimized, and then we allow them to basically take any of those experts and fine-tune their data, and then they just API like they would with OpenAI type of models.
I see. I want to say, I'm always kind of in awe of CEOs running hardware companies. It seems like such a challenge to handle like supply chains and know how much you're going to build. I'm kind of curious, like, do you pre-sell chips and then go, kind of find the supplier? Like, how do you sort of balance and, kind of forecast demand for your offering? Like, how much lead time do you need to know how much you're going to manufacture? It's always been hard. It's always been hard. And then COVID hit and made it that much harder because the predictability of the lead times through TSMC was just hard to manage. And so recent's gotten better, but we went to as long as 50 weeks as far as waiting for chips. And so there's a lot of buffer that we had to go create. Now, when I started the company, within the first 3 years, we raised $1.1 billion in capital, right? People are, well, what do you need so much capital so quickly? Well, part of it, as a choice for the company, we wanted to remove that risk, that we would sell and not have material, right? And so what we ended up doing was, because we're a venture-backed company, we weren't worrying about, quarter by quarter rev rec and publishing, profitability to public investors. What we decided to do very early was just pre-buy on a customer's behalf. And that worked out really well. Now, as kind of these larger size deals, there's a limit to how much you can pre-buy, right? As these larger deals have now come in, then we're having to actually stage them with customers and be able to actually deploy them in phases so that we can get the customer going, right? We can get the customer going. They can start doing a lot of the training work, get a lot of the system integration work, getting some of the data, all of that going while we actually start building up a larger set of inventory so that they can actually deploy the second and third waves, right? And so there is a lot of complexity that the team goes through to make it to tie those two things together, right? Because ideally, I love the software side of the world where you want it, I drop it, and you just fire it up in the cloud, off you go, right? And for us, there's this layer of, well, if you want X number of units, it's going to be this time. If you want Y number of units, and if Y is significantly bigger than X, then we've got to do a bunch of planning, right? But here's the thing I like about it, that with our platform, once it's in there, the customer gets so much flexibility, right? Because you can use all these different things. So they can use it on the cloud, they can use it on-prem. They have this flexibility of where to run these models. And so most of our customers don't use it just on SambaNova. They use it as a flexible compute, so they can actually run their workloads on different types of hardware and not be so dependent on whether they can get cycles one place or the other. And I guess, what does it mean to use it in the cloud? Like, can you put your servers inside of AWS or something like that? Like, how does that work?
Well, today what we do is for customers that have their data already secured in a cloud environment. Let's just say most of our clients have a secure enclave because we're mostly in the kind of highly regulated environments. So they have a secure enclave where they've actually carved out some space where they can do all their work, and there's some privacy certification that's been done, right? And so with those clients that are already there, we're able to create a secure pipe into a secure environment. In some cases, for a bank, for example, we have a system sitting behind a lock cage in a colo where they got stuff, but most of their activities through the cloud, and so there's a secure pipe that runs from there over to this environment. We actually do the Gen AI computing that's required on our hardware there, and then it's all seamlessly transfer back into the cloud environment so you can transact on the cloud, right? And so that infrastructure looks like it's all there, but we actually host the servers in colos and like an Equinix or something like that, wherever it is that the customer needs it, right? So that it fits into their security protocols. And it's actually something they've been doing already. They do this with various different types of integrated systems today. And so we just lead into that same model so that we don't have to teach them something new.
Mm-hmm. But that's really like I guess that seems like an on-prem deployment for you then, right?
In some cases are on-prem. In some cases, we've already pre-stood up systems, right? We've pre-stood up a lot of systems so that you can wake it up within minutes, right? So if you come into SambaNova and say, hey, I want to try this, there is no lead time for you to come in and wait for us to install. You can come in, you can fire up your session on the cloud, you can be on SambaNova within the hour, right? Or within minutes. There's some work that you do to kind of get your account set up. But it kind of reduces the time to actually get onto a system just because the system's already pre-installed and up and running, and it just becomes part of the service, and we just have to do the provisioning.
I see. I wanted to ask you about kind of talking to executives that maybe are less familiar with with AI and machine learning. I mean, it seems like one of the things you talk about on your website and talk about to me is sort of like kind of making this, more accessible to a broader audience. And I'm curious how those, conversations tend to go, how you talk about like what use cases are possible, how you would even sort of scope out what the size of an engagement should look like on a speculative project.
Yeah, for the most part, we go into places where people have already tried. They've already tried Gen AI through OpenAI in some way, whether that's ChatGPT or GPT-4, and OpenAI has done a tremendous job, kind of really building up that business, showing people what it could do for them, right? And many of them have figured out kind of, okay, I can use it for these things, but I'd love to use it for these things, but for whatever reason they can't, right? Because they need to access private data. They need to actually train it further, fine-tune it further on their private data. It's regulated. They need to actually be able to audit it, whatever, right? There's a bunch of different reasons why people come to us and they say, okay, well, I would love those GPT-4 capabilities, but I have to have it in the private, right? And so we come in and we say, okay, well, what we're able to do is we can give you those wherever your data sits, right? In fact, in the same subnet as your data, because we can put a trillion parameters on a small footprint and just drop it right into next to your data. So from an InfoSec perspective, good for your data, good for the model, right? We're not asking you to move the data elsewhere. No, we're not asking you to expose it to somebody else. We just drop it wherever the data sits and we start training it off of that private data. And so that becomes a very usually like the step one for us that, if you already have a good sense of what it is that you want to do it, but you can't do it because you have private data restrictions, right? SambaNova can give you a trillion parameter capability dropped on the same subnet as where that data sits. Now, the second step would be then, okay, well, now I'm there. How do I start getting value out of it? Because I want more than just a model that interprets it. Like, how do I start integrating into my daily workflow? And so in that case, then we actually have a set of things that we already pre-canned that we say most people in your space, if you're in financial, and yes, they start working on these things, right? And so we can show up with pre-done applications or use cases where you can leverage that private data and fairly quickly integrate those into a workflow. And you'll see, ultimately, this, right? It's ultimately AI about raising the productivity of your workforce, right? That if you can actually get everybody in your company 10x more productive, then you're already getting wins. And so for us, it's kind of finding those groups where there's significant advantage in being able to get information, highly accurate information, in their fingertips, and they can generate documents, generate summaries, create these things very, very quickly, where otherwise it would have taken them significantly longer.
And what are those use cases? I mean, I would love to make my company 10x more productive. If you make them 10% more productive, I'll certainly buy your service. Like, what are the use cases that you typically go in with, or what are the most popular things that enterprises are doing right now with your stack?
the more complicated your product is, the more valuable we can make it. So some company we recently announced this partnership with Analog Devices, right? And so, as you know, Analog Devices is a 50-plus-year-old company, amazing company. They power all these different things that you didn't even know they were in, right? These devices, and you look at the complexity of their offerings and how much they actually do with these devices. It's hard for even their own folks to be able to interpret what it all does, right? And so what Vince Roche, who's the CEO of Analog Devices, has decided to do is he wants to lean into AI and apply AI to really help their customers and their field to be able to interpret everything that the product does. Imagine like the specs and being able to figure out which part does which thing under what voltage and current conditions for this, right? I mean, being able to have something that already understands all the products you have, all the specs that you have, be able to actually very dynamically respond to the needs of the market. It's just an amazing thing that companies are doing these days to really be able to elevate their company's efficacy and actually creating value for their clients, right? And so this is one of the things that, again, the Analog Devices guys have been, very incredibly generous in being able to explain kind of how they view AI and how they're using some of these things. And so for clients that are able to talk about their use cases, we always appreciate. And then, of course, as you know, there's many of them that kind of do things that they are able to talk about. But I would say, just being able to take large amounts of information, the more complex the information, the more valuable it is, and make it accessible to the non-technical person, to the the person that doesn't understand all the details, and yet they need it. They need it in order to actually make a connection between a product and a use case, or a product or a service, or something that the market needs, or something that the market is asking about, and be able to respond correctly.
I'm curious how you think about regulation. I mean, we've seen, the Biden executive order, like the EU AI Act. How does that affect your business, and how are your customers thinking about that?
Well, it's front and center, right? It's front and center. It's important. It's something that I think everybody's thinking about. Well, how do we make sure that we understand what these things are really doing? Right, these models are getting so complex that we're not, we don't always feel like we have a great understanding of how it works. And so I think people are thinking about what is required for us to get a better understanding to make sure it's doing the right set of things. I actually happen to believe that there will be an entire industry that's going to get created for this. Right? You think about cybersecurity. When we started with the internet, cybersecurity became such a big thing across the board, just because suddenly the demand for that level of protection and that level of understanding was there. Same thing here, that I think the demand to really understand what these models are doing and be able to explain, right? Be able to trace kind of exactly how we arrived at a certain decision, how we arrived at a certain course of action. I think that's going to continue to be really, really important. And so this is, for us at SambaNova, one of the reasons why we decided to lean into open source. Basically, everything we do is off of open source. Why? Because, one, I can share with you the model in itself, the weights, how it was trained, right? We can open it up for anybody that wants to start going in and testing it, auditing it, and doing the things that we know is coming, right? We know is coming. When it's closed source, black box, it's much harder for you in a regulated environment, or for companies that are worrying about and the regulations coming in, to be able to adhere to those to those regulations, right? And so very early on, SambaNova, we just decided, okay, we've got to lean on open source and be able to allow anybody to see how these models were constructed, right? Open it up. How were they trained? What data sets were they trained for? Where the weights? You'll be able to audit all of it, and so that you feel comfortable that if you're going to deploy this, right, in your mission critical applications, making real decisions in your business, right, then you can actually put some processes in place to actually make sure that you've been able to validate it, right, audit it, check it, and make sure that you're comfortable for your business.
One One issue I imagine you might have is, you're building hardware, which is on a much slower time scale and tends to have a different kind of engineering culture than software. And you even make, really like customer facing, UI heavy software, which I would think would need to iterate like really fast, probably have a more kind of agile process. Do you have any kind of, I don't know, like tension in your company around these? Like, do you feel like you have kind of different cultures around the sort of hardware and the user-facing software? Are you able to kind of put that all under one organization? Is it possible for, like a single product owner to manage all these things that are operating on such different scales?
Yeah, it's true. I mean, yeah, you got chips that want to operate on multi-year scale, right? We're releasing these model updates. These COE updates are happening every couple of weeks right now, right? And so, it's complex. But here's what I'll say, Lucas. When people talk about full stack today, there are a lot of model companies that are out there looking for a chip, which, obviously for a lot of different reasons, we're 100% behind, but we definitely believe that that's the right direction. But what you're bringing up is actually an incredibly important thing, right? The reason this company we've been able to do is because we've done it for so long, right? That we've done it even prior to this company. A lot of us have worked in a similar environment before, and trying to create the right abstractions, right? As you know, like, somebody on the compiler side actually doesn't want to know all the gory details of the RTL code, which the RTL engineer, the chip engineer, would be more than happy to explain to you how these latches work and how the logic works, the Boolean equation. I don't care. Just tell me how, just tell me what flags I get to have, right? Which bits I get to program, and just leave it at that. And then as you go up, like the ML engineer actually doesn't care how you actually manage to turn this, tensor, graph into this. They don't, just give me the abstraction layer to do these things. And so being able to define those in a way that allows each of those groups to operate at a certain velocity, right? But still being able to take advantage of the fact that you're full stack, right? Because otherwise, what's the advantage? If I have all these capabilities, but my top layer, my machine learning people don't know how to take advantage of data flow architecture, well, how was that any help, right? And so being able to actually create the advantages of top to bottom, where we can go in and say, okay, well, we want, for example, we're shipping 256K sequence length today to customers, right? And so we were doing this middle of last year, right? And so being able to say, okay, here's a model with 256K sequence length, and we're able to map it on a single chip, right? Well, how do you do that, right? And so being able, because that's not something you can today easily do on GPUs, but how do you do that in the construct of these interfaces without having to get it into some bespoke function, right? You want to do it through these standard interfaces so that any model that's presented to it works, right? You want to use as standard of an interface as possible so that you can get the breadth, because models are changing so fast, and you don't want to be in this position where you created a hardware platform that doesn't support future models, and then you have to wait years before the new chip comes up.
You have Samba Studio, which I think is this really ambitious product. It kind of subsumes a lot of stuff that we do, here at Weights and Biases, is like a complete, it looks like a complete IDE, experimentation platform that you've built. It seems to include a model hub and project management. And I was kind of curious, what you've learned from your customers along the way in building that, and if there's any other big pieces of functionality that you're thinking about adding to it.
Well, I think as you know, we like to partner with folks as much as possible. When we started creating Studio, it really was a way that we could actually give people early access to it, right? But as you know, we also don't force our customers to only use our tool sets, but we needed a way that customers can come in and engage with the products in a way that they already understood, right? You can go in, you can pick the model that you want to use. You can, it looks familiar to you. You can kind of set the hyperparameter tuning, recipe, it restores all of that for you, it registers the model, the data set, all the basics of what you want. And then somebody comes in and say, hey, I want to do slightly different, use somebody else, use this partner, that partner. We're more than happy to kind of integrate to those, right? Because we know they're in different parts of their journey. They've already started with certain tool sets, already started with certain types of applications. And so we want to be able to give them access to our technology, even if it's pieces of it, right? And this is kind of the way we think about it. We're full stack from chip all the way to the model, but we also know that not everybody needs to take advantage of our entire stack, right? As we talked about, we may have a trillion parameter model that we composed off of open source, but we have lots of customers like, you know what, I have my own models, I can put, all these models in. And so we are, we're just happy to go and engage with our clients where they need us, right? Some people need us at just the hardware. Some people need us across everything because they don't have, access to, any part of it yet, right? And so, but, for the most part, I think if you look at us as one bookend is NVIDIA chips and the other bookend is GPT-4, that's kind of more or less where we kind of, stay. We don't do that much in terms of like all the bells and whistles on MLOps. We really lean on partners to do it. We don't really do a lot of the application side, like legal assistant or code gen. Like we lean on others to help do that. What we do is we deliver a computational platform with our own chips on one bookend, and then we, for whoever wants, we give you a multi-trillion parameter model on the other end with a composition of experts as composed through open source models that we are able to then aggregate together, fine tune, adapt, and align, and then we kind of deliver it as a single fully hardware optimized model, right? And so those are our bookends, and for the most part, everything that you guys see us do is basically like getting, keeping up with what's changing, getting the better versions of it out there, getting a little more seamless, tying into more partners, tying folks like yourselves and other people, other technologies that people like to use, and trying to make it simpler and easier for you to integrate this with the sole focus on this is an enterprise focused solution, right? If you want enterprise, you want to try to deliver it, train it against your private data. This is kind of our offering, and you can deliver that and deploy that wherever you want.
Okay, I have one more question. I'm really curious about this one. When you look at your customers where you deploy these models, or this whole kind of full stack system, obviously you provide a lot, but what's the biggest issue that the customers run into along the journey from having like a business use case that they're trying to solve with LLMs or machine learning or whatever, and actually getting it deployed and useful?
I don't know if there's a single one. We've kind of run into a bunch of different things that people are.
Okay, tell me all of them then. I want to whatever all the unexpected bumps along the way.
Yeah, data integrity is a big part, right? I'm trying to figure out what got trained into what, right? As they're training these models and fine tuning, what got trained into what, and how do I keep track of it, right? So that's so there's a bunch of things that we try to do when we actually fine tune these models on behalf of our customers to give them a running record. It doesn't even have to take years. Just a few months, they already forgot, right? Like just the amount of change of what's happening, you just kind of lose track of, well, what went into this one versus that one, and that person, maybe the person that trained it left the company or whatever. There's just a lot of complexity in just keeping track of all these models and data that's changing and getting generated, right? So that's one piece of it. I think there's a bunch of it that's tied to how do you keep access clean and clear between, so I trained this model, especially in our environment where we have very sensitive data, right? If you go into governments, intelligence communities, or banks, or whatever, how do you know if the person asking and prompting those questions actually have access to whatever they're getting answers for, right? And so we've done a lot of work trying to create these segregated environments for the model so that you can actually have access control for specific parts of the model. If you ask, our trillion parameter model question that you don't have access to, it will return, I'm sorry, you can't, you don't have, get access to that information. So, but that part of it's really hard. There's a lot of work that, banks are doing to try to figure out, are we okay with that, right? Because if you disclose information through the model accidentally, this is really bad, right? And so it's really bad. And so you can't deploy that until you've got through those, through that testing. I'd say there's still quite a bit of, there's quite a bit on breadth of accuracy for a broad enough range of tasks, right? That will show up when then people say, I can do these things, but then they move that over, they take that recipe, they want to deploy that recipe in 4 regions. And as soon as you move to a different region, it hallucinates like crazy, right? And so how do you actually create localized enough adaptation, alignment, so that you can get the accuracy you need without having a completely different model, right? Without having something that is done from scratch and you're redoing all over again and you can't manage it all. Right? And so there's a bunch of things that we've kind of had to deal with it at that level. But a lot of it is just kind of the scale of it. As you go into production, you went from a controlled data set with a controlled model producing a controlled set of benchmarks to now I have open data sets with models deployed multiple places with a large number of users where the responses aren't easy for me to measure, right? And that's kind of been really where we've been spending a lot of time with clients as they're moving from these lab and kind of kicking the tires over to getting them into production.
Totally. Interesting. Well, awesome. Rodrigo, thank you so much for your time. This is really enlightening for me, and I'm sure audience is going to love this.
Yeah, no, it's been great. Yeah, thanks. And it's always great to see somebody else in the space, and I think we've been talking since both of us started our companies. I feel like and so
totally.
So I think it's great to see people who kind of had a similar experience of this journey. Right? It's been what amazing last 6 years it has been. Right? Just kind of watching the industry evolve and the amazing thing about it is I think the next 6 years is going to be even more dynamic. I think, the big use cases are yet to come is what I believe, what people are really going to be able to do with it is yet to come. And I think we've got an exciting opportunity ahead.
Totally. Well, look, we really appreciate your business and it's a pleasure working with your team. So, yeah, thanks again. And I hope we can chat soon.
Yeah, sounds great. Thanks for having me.
Have a good one. Take care. Thanks so much for listening to this episode of Gradient Dissent. Please stay tuned for future episodes.